Thank you to our zone sponsors. And to all of our product sponsors.
Hey, I'm Matt Whitbeck with Whitbeck Construction, and we're going to be talking about the elephant in the attic, bathroom fan ventilation. This is a big deal, and years of doing energy audits, inspections, remodeling, and new construction, I see one constant thing done wrong in almost every home. It's the bathroom fan ventilation. We see a lot of rot on the roof deck surfaces, poor installations that are causing water to build up on sheetrock, mold issues. All of these things amount to one big problem. Our clients are dissatisfied, and the vapor inside the bathroom isn't going outside where we think it is. Is it getting done right in your project? We're going to take a look with a veteran installer of HVAC systems, and he's going to show us some tips and tricks as to how we put together these systems to better the house, make sure we improve how fluids move out, and have you set up to make sure you can either make money on that remodel or set yourself up for limited liability with new construction. Let's take a look. So we're here with Nick Armstrong, a specialist in plumbing and HVAC work, and we're talking about bathroom fans.
Sure.
All right? Ductwork in general is a really big deal to get put together correctly, and when we think about bathroom fans, you know, I think a lot of people don't really give them the attention that they deserve in construction. So vapor and air are both fluids. And with that being said, what's the right kind of ductwork we want to use for a bathroom fan?
We need sealed ductwork, is what it comes down to. We want to keep what is inside that pipe, and what's on the outside of it, on the outside of it.
That's a good point. There's a lot of things that I've seen in buildings when we've gone in and done inspections, remodels, energy consulting work. And I would say the bathroom fans are definitely up there on the thing I see done wrong more
Sure.
times than not.
Sure.
Beyond just seeing them ducted to the wrong place, like dumping them out maybe in the soffit in the
Right.
great Northeast where we are, so that it just blows hot air up underneath a big pile of snow on the edge of the roof, melting it, causing ice dams and backups. We see them done incorrectly where they're just ducted into the truss or attic space, and then they expect the ridge vent to take the rest of that moisture and air out of the building. And that's really not what that system was designed to do. That system was designed to move naturally convected air that was going to pick up from radiation and air movements so that, you know, it could keep the roof a consistent temperature.
Sure.
So when we put pressurized air in there, we can see a lot of problems, especially when that pressurized air is coming with a lot of moisture.
Right.
What other things do you see as being issues inside flexible ductwork, which we see more times than not being
Right.
placed into that attic space?
Yep. Well, we don't see it stretched out, and that's a proper installation as it needs to be stretched out. Otherwise, we're going to be storing water within there. You also see that the way that they bend it, it's creating traps, which is not a good thing, obviously. You know, water sitting in a trap, not going anywhere, not able to get out. It's going to create, you know, mold problems and other issues as well.
That's a good point. You know, bending up and around things, and we see it so often laid across the bottom cords of the trusses, and it just slowly conforms to that wood space. And as the insulation settles over time, we get these low pits.
Yep.
And where we are with the humidity changes, one, you're sucking a lot of moisture out, and then it gets up into this cold space, right, above your insulation plane, and it's going to condense.
Yeah.
So now we go from a vapor to a liquid. And I've even got phone calls from homeowners that they thought their roof was leaking.
It's coming
and
out
I've
of the
spent
fan.
hours up on their roof looking for a leak point, can't find anything, climb up into the roof trusses, and I find a flexible duct somewhere draped into a bay that filled with water over 4, 5, 6 years and eventually burst and drained down through the drywall. What happens when we create that many bends in a pipe? What's happening to the desired size of the pipe as it's trying to move air?
Yeah, Matt, so when you're talking CFMs being pushed through a fitting, let's say a 90, okay, what happens is that it's going to hit that 90 and it's going to have to be pushed around it rather than a straight shot through it. And it's going to create a drag. It's going to create a back pressure when it hits that. So we want to try to do our best to eliminate that if possible.
So I would think then if we have turbulence within that ductwork, that something smooth and straight is definitely going to help us move more air cleaner and faster without any restrictions, right?
Absolutely, and it guarantees that you're able to pitch for that condensation that we talked about. The closer we get to the outside, you're talking cold air, and we have warm air, which is also moist in a vapor form. What's going to happen when we get close to that outside is, it's, like you said, it's going to condense. And if it's not pitched appropriately, it's going to back pitch on us, and it can come back through that fan, and then they're calling you. And then you're up on the roof looking for an issue.
So either that could come back and damage the fan because we're pulling it back into the electric components, right? It could cause a leak or just build up a funky, gross, organic mess that sits there as this pool. And then if we get any back pressure later on, it could suck that gross, stale, funky, just moldy mess back into our house. And then once we start moving those mold spores around within a bathroom, it's not going to take them long to stick to anything else and then start growing more mold. So we really want to make sure we're evacuating that, pressurizing it well, using the right diameter pipe, and then, you know, get a downward pitch like you're saying. So sealed, pitched, in an appropriate length. And we like to make sure that, you know, our terminations as they're sticking out are coming out a wall, like a gable wall, or low enough away from the eave line where that moisture isn't coming back up into a soffit and then being sucked into the house. So, you know, a couple of decisions that need to be made when we're thinking about how we're going to run that duct work, where we're going to place bathrooms in the house. Maybe it means in the architectural drafting stage that we move a bathroom to a better location. Just to make sure that it vents properly, because we want the house to work well for a long time, not just look nice or have ease of flow in one place or another. And architects are great at coming up with creative ways to get around something. And if we address that elephant in the room and say, hey, this is a bad spot, then how do we get around that? But addressing it up front, I think, is an extremely important thing. But this is an easy thing to retrofit. We've done it in tons of remodel jobs, and it's even easier to do in new construction. So let's take a look at that bathroom fan installation, and we can talk about the inside and the outside parts of what we do to seal this off properly.
Let's do it. All right, so what we got here is a Panasonic Whisper Green Select. It has a variable timer on it. You could set CFMs on it as well. We had mounted our brackets up here, got those nice and secure. It's important to put the fan in a good location to where it's going to be able to pull and draw and do its job for us. Also in a location where we're going to be able to pitch it far enough to be able to move our fluids out of there. Now, what we like to do is we have rigid pipe up here. Now this is a foam core PVC, 4-inch. And we have it pitched at a 1/4 inch per foot, which is a standard pitch for, you know, any kind of waste style pipe, whether it be sewage or drainage. So we have the rigid pipe out towards the exterior of the building so it can pitch down, and we like to use our flexible here so that we can make that connection. So one of the reasons why we use the flex pipe here is for sound dampening purposes, okay? Now, we don't have to worry about condensation happening this close to the fan motor itself, so it's okay to use flex for a short distance entering our length of pipe. Another reason why we use flex in the beginning of this connection here is because the sound dampening and the vibrations that would be caused by rigid piping, you would be able to hear that through the fan motor, and this thing's quiet as can be, so we'd like to try to keep it that way if possible. So what I got here is a piece of galvanized stack pipe. You see it in a lot of terminations for, you know, smokestacks, any kind of exhaust that you'd be using for penetrations outside of the building. We want to make sure too, even when we use small pieces like this, that we keep our tape side and seam upwards. And that the reason being is that it won't, you know, if this fails for some reason, the tape here or this seam, you're not going to have water dripping down through it. And we also want our tape to be seam side up as well. So just to reinforce our connection between our rigid pipe and our flex pipe here, we use the tape as we talked about before, but we also use these clamps as well, which could just be put on with a simple torque wrench. Okay, so I'm going to go ahead and make this last connection using our flex. And it's very important as well that we stretch this out. okay? And one of the reasons being is that we don't want any water moisture to get trapped within these ridges and to stay stagnant. It also helps with the movement of CFMs from the fan motor. So I'm taping up our connection here. Once we're taped and sealed appropriately, and we've made sure to get all of the air bubbles out to make a proper connection here, I'm just gonna tighten up my clamps and secure this connection even further. Okay, we're gonna do the same thing to the other side here. So again, very easy to install, but overlooked, like Matt said. So we have our brackets in here. We made sure we're nice and level. We have our unit nice and secured. We have our flex connection with our tape and our clamp. Going into our rigid pipe, sloping downwards, we got our pipe secured as well with J-hooks. And again, we're at a 1/4 inch per foot pitch. And it's about as simple as that.
All right, now that Nick has taken care of the interior side of this ducting, it's a great time to take a look at where this penetrates through the wall. So this might be something that Nick picks up himself as the plumber, or it might be something that we put on the sider's head. Maybe it's the framer. It all depends on a lot of things. But one thing we know is this needs to be sealed off correctly to make sure that we're air and water tight. If air and water are leaking into the substrate of the house, we're gonna have poorer indoor air quality and we're gonna have rot set into the house. So a few things that we have to make this install work. We have some elastomeric sealant, Flex Wrap Easy, some DuPont flashing tape. We have a pre-made J-block that's all set up, ready from Diamond Coat, and we have our hood for our penetration. You'll see that the pipe that Nick had installed through the wall is sticking out a little bit more than an inch. We've cut the Tyvek out in a square around the outside of the round duct as it came through the wall. After I've removed the Tyvek from around our substrate and the pipe penetration, in a similar fashion to what you would find in any of the installation instructions for head flashing around a window or penetration, we're gonna cut a few 45-degree angles a few inches up. This will allow us to fold the Tyvek up and complete a shingle-style head flashing. I'm going to remove the thinner piece of tape from the back of the Flex Wrap Easy. I'm going to apply it to the wall, onto the pipe first, then I'll remove the remaining piece of tape material and flex the material around the base of the pipe. I'll repeat that on the top to again make sure that I'm in a shingle fashion, overlapping in a sequential order from top to bottom. In this next step, I will take my 3-inch Tyvek tape, fold down the headlap that I previously folded, and tape in both 45-degree angles. In the next step, I'm going to take my pre-made block, place it on the wall dry, trace around the outside to mark the flanges. I'll then bed the top and 2 sides with an elastomeric sealant, leaving the bottom open to weep any water if it builds up. I will then tape the head of the pre-made unit to the Tyvek, ensuring that we have a shingle fashion. In this particular situation, I will not recut the Tyvek to cause a shingle lap here, as I'm confident if any water leaks past this upper point and into the face, it will come out across the bottom where we've already sealed. I think all of these tips and tricks are really important for somebody to be able to think about on their next install.
Sure.
So Nick, thank you very much for coming in.
Oh, my pleasure.
We hope that these tips and tricks help you build better, more sustainable, long-lasting product for your clients. We appreciate you checking us out. Thanks for watching the High Performance Zone.